हेलो एवरीवन, मैं हूं विकास साहू, असिस्टेंट गेस्ट प्रोफेसर एसडीएन गवर्नमेंट कॉलेज अर्जुंदा, डिस्ट्रिक्ट बालोद, छत्तीसगढ़। अ, आज हम देखेंगे एमएससी मैथमेटिक्स फर्स्ट सेमेस्टर का एक बेहतरीन और इम्पोर्टेंट टॉपिक, लॉरेंस सीरीज एंड इट्स सिंगुलरिटी। So first, what is Lorentz series? If we are having a function f of z and we are uh, checking at z0, it is either analytic or not. If it is not analytic at z0, then we can apply Taylor's theorem at that point. हम उस पॉइंट पर टेलर्स थ्योरम अप्लाई नहीं कर सकते। तो ऐसा कोई पॉइंट जिस पर हम टेलर सीरीज अप्लाई नहीं कर सकते, सो उस पॉइंट पर हम लॉरेंस सीरीज एक्सपांड हम उस पर अप्लाई कर सकते हैं। लॉरेंस सीरीज जो है वो एक मैथमेटिशियन थे, पियर अल्फांसो। उन्होंने हमें ये लॉरेंस सीरीज इंट्रोड्यूस कराया था इन 1843। लॉरेंस सीरीज एक्सपांशन और टेलर सीरीज एक्सपांशन में द बेसिक डिफरेंस इज दैट टेलर सीरीज हैज़ ओनली नॉन नेगेटिव पावर्स ऑफ z and Lorentz series has both. It means Lorentz series has both non-negative powers and negative powers of z. So here we can easily see that f of z is of the form summation n varies from 0 to infinity c n z minus z0 to the power n plus summation n is equals to 1 to infinity bn upon z minus z0 to the power n. So it can easily see that the function f of z having non-negative powers of z and having negative powers of z. So the second part is called the principal part of that Lorentz series, and we can say the first part is analytic part or regular part of that function f of z. So here Cn is nothing but it is the integral of the form 1 upon 2 pi iota integral over c f of z upon z minus z to the power n plus 1 dz, where n comes from the whole number, that is 0, 1, 2 and so on. And Pn is also 1 upon 2 pi iota integral over c f of z upon z minus z0 to the power minus n plus 1 dz, and n varies from 1 to and so on. It means the positive integer. Now if we calculate any function's Lorentz series expansion, so we are having the function f of z is equals to 1 upon 1 minus z, and we can expand this function in two ways. Inside the region mod z is less than 1, we can have the expression of the form summation n varies from 0 to infinity z to the power n, that is non-negative powers of z. And outside the region mod z is less than 1, we can expand 1 upon 1 minus z is of the form summation minus 1 upon z to the power n, whereas n varies from 1 to infinity. So basically f of z is not analytic at z is equals to 1 because it is not defined at z is equals to 1. But outside the region and inside the region it is analytic everywhere. Here we have the diagram also. So this is the outside of the region and this is the inside the region. So everywhere analytic inside and outside, but it fails to be analytic at exactly z is equals to 1. So we are having Lorentz series expansion at z is equals to 1 of this function f of z. We have another example, f of z is equals to 1 upon z plus 5. So we are given two regions outside the circle at centered at 0 and radius 5, and inside the region. So it can be expressed as like equation 1. So f of z can be written as 1 upon 5 into 1 plus z upon 5, and it can be expressed of this form 1 upon 5 into 1 minus in bracket minus z upon 5. So basically we are forming the Lorentz series expansion like as like we are introduce our Lorentz expansion. So f of z is expressed 1 upon 5 summation n is equal to 0 to infinity and minus z to the power minus z upon 5 the power n inside this region, and outside this region we can easily expand our function f of z in this form. So here our f of z is having two parts. Firstly, the non-negative powers of z, and the second part having negative powers of z. So first part is nothing but it is the Taylor series for that function, and the second part is non-negative powers, and that includes our that makes our Lorentz expansion. तो लॉरेंस सीरीज एक्सपांशन में आप नेगेटिव पावर्स भी देखेंगे, दैट इज प्रिंसिपल पार्ट ऑफ दैट फंक्शन, एंड द नॉन नेगेटिव पावर्स इज आवर एनालिटिक पार्ट और रेगुलर पार्ट. सो it can easily calculate any function's Lorentz series. Now, what is type of singularities? So basically, there are two types of singularities, mainly isolated and non-isolated. And non-isolated singularities में हम तीन टाइप की सिंगुलरिटी देखेंगे. फर्स्टली पोल and remote singularity and essential singularity. So what is singularity? If a function f of z, yeah, in real life any object is not defined at some point or exceptional state where it fails to be behave in some particular way, such as differentiability. अगर हम रियल लाइन में जाएं, अगर एक फंक्शन हम यहाँ पे सपोज करें, एक फंक्शन हमारे पास यहाँ पे है f of x is equals to 1 upon x. So if we talk about point x is equals to 0, so function would not be defined properly. It will be either plus infinity or minus infinity, and so it again we have function g of x is equals to mod x. So we can easily check that at x is equal to 0 the function mod x is not differentiable because it have the graph of this form and we have the sharp edge at x equal to 0. So we can say that the function g of x, that is mod x, is not differentiable at that point. So this point are these points are said to be the singularity, that is for f of x is equal to 1 upon x, the x is equal to 0 is said to be singularity, and again mod f x के लिए हम x is equal to 0 को हम बोल सकते हैं singularity. So first we come to isolated singularity. What is isolated singularity? अगर कोई पॉइंट है z0 किसी फंक्शन f of z को लिए हम उसको आइसोलेटेड सिंगुलरिटी बोलेंगे यदि इस पॉइंट पर वो फंक्शन एनालिटिक न हो, बट दैट फंक्शन शुड बी एनालिटिक एट द नेबरहुड ऑफ दिस पॉइंट. उस पॉइंट पर एनालिटिक नहीं होना चाहिए, बट एनालिटिक कहाँ पे होना चाहिए? उसके नेबरहुड पे. तो दैट पॉइंट इज कॉल्ड आइसोलेटेड सिंगुलरिटी. अदरवाइज we say the point z0 is non-isolated singularity. We are having examples of the form f of z is equal to z square minus 1 upon z into z square plus 1 into z minus 2. So here are z is equal to 0 plus minus iota and 2 are isolated singularity, and 10 z upon z has the singularity at z is equal to 0. So now we come to pole. What is pole? If any functions f of z has the Lorentz expansion of this form and the principal part having finite number of terms, that is we can have example here. Here this is the principal part and it has finite number of terms, so that the point z is equal to z0 is said to be pole of order n. Here the last power of z upon z minus z0 is the power n. So z minus z0 की पावर जो n है वो यहाँ पे उसका ऑर्डर कहलाएगा, किस पॉइंट का? z is equal to z0 का. If you put b1 non-zero and other points b2 b3 up to bn, equals to 0. So this expansion can be written as of the form summation c and z minus z0 to the power n plus b1 upon z minus z0, and here z is equal to z0 is pole of order 1. Again we come to remote singularity. What is remote singularity? It is also a non-isolated singularity. If any functions Laurent series expansion has principal part 0, उसमें principal part नहीं होना चाहिए, तो that singularity z0 is said to be removable singularity. For example, we are having sin z upon z. Here z is equal to 0 is removable singularity because it has not any principal part. And again we come to next slide. Essential singularity. What is essential singularity? If in the Laurent series expansion the principal part contains an infinite number of terms, then that point z0 is said to be essential singularity. So we are having example f of z is equal to 1 upon e to the power z minus 2, that will be of the form 1 plus 1 upon z minus 2 and so on. So here z is equals to 2 is the essential singularity because it has infinite number of terms in the principal part. Okay, so I think it will be easily uh, understood that what is essential singularity, what is remote singularity, what is pole. So if this video is helpful for your study, then like and share and comment. Thank you.